Hey everybody, and welcome back to Algebra 2 Online. So today I just want to do a little bit of quadratic review in prep for the quiz that's coming up. So you will have to do some just solving of quadratics, and I always think it's best to practice the hard ones and then be assessed on the not so hard ones. So this is an example of one that looks really scary, I think, and then it turns out to actually not be so bad. So this actually is a quadratic, because one thing that I want you to see is, like, if you have x to the 2,000 here, then if you divide that in, you get like x squared here. And if you divide it in here, you'll get just x, right? So then this whole thing can simplify to this. And anytime in math when you have fractions, it's good to get rid of them. So I would personally multiply this thing by 4. And then I can kill the fraction on the left here. And if you multiply the right side by 4, you get 97. So then it's starting to look a lot more like a kind of normal quadratic. And you could move this over, and you could just try to factor. But actually, I'm going to show you guys another one just completing the square, which, again, I said before, it's not necessarily like the best way to solve them, but it's good to just kind of practice this. So this is my b, and the thing that I need to add to both sides when we complete the square is just b over 2, all that stuff squared. So I'm basically going to add a 4, right, to both sides. And that's because, this is 4 divided by 2 is 2, 2 squared is 4. Now this thing should, on the left, like, factor into a perfect square. And it would be x plus 2 and x plus 2. And then if you add 4 to 97, you get 9801. Then I'm going to just do like the square root, like, plus minus trick. So you would get, this is actually a perfect square, which, I just made this problem up, so I know, I knew it was going to work out nice, but this is plus or minus 99. And it's really plus or minus again because there's two things you can square and get this, right? You can square 99 and get this, or you can square negative 99 and get this. And then just minus 2. And that would be your answers. I don't know what this green thing is. Ignore that. And so if you do negative 2 plus 99, then you get 97. And if you do negative 2 minus 99, you get negative 101. And just to show you, if you go and plug this into like a graphing program, these are actually this is what you'll actually get. So you can see this is the negative 101, and this is the 97. So you definitely don't have to do it with completing the square. Most times I'm never going to do this. It's just good practice because we just learned it, so I wanted you to see another one. Probably what I would do is typically I would take this part, move it over, and I would just do quadratic formula because the number is so big, and you're going to get the same answer, so it works out nice. All right, so this is just kind of a concept type question. So it's saying, what values of b does this quadratic have a minimum value of 6? Okay. Minimum values for quadratics are basically, if you have like a quadratic like this or something, right, its minimum value is always going to be the vertex. It's an open up quadratic because this x squared is positive. If it was like a negative x squared, then those kind of quadratics have maximums, right? They're like upside down, and you'll have like a max value right there. But we know we have something like this one. And so we just need to figure out what b in here guarantees that this is a 6. Okay, that it has a minimum value of 6. So that's the question. B is what to make the minimum value like a 6. So since it has something to do with the vertex, it makes sense to use, we're in standard form here. Standard form. And we need something with the vertex, so makes sense to use like the line of symmetry. So we know, B is all the number in front of the x, which in this case is actually all of that stuff, right? So B is actually like negative 2b. And then A is 1. So then this simplifies a little bit, and you just get negative B. So x is negative b, which means that if we just plug in negative b for x, we should get the y value, right? And of the vertex. And we want the y value of the vertex to be 6. So basically what we're just going to do is set up an equation. We want the y value to be 6. And then we know that the x is like negative b. So squared, and then minus 2b times x, which is negative b, and then plus 7. So all I did is I just plugged in the things I want. I want the vertex to be sitting at the y value of 6, so that's where that came from. And then the x we just found for the line of symmetry was negative b, so I just plugged in negative b. And now I can just go and basically finish this thing out, and I'll have what b needs to be. Okay, just put that in, and I realized I made a little mistake. So negative b, right, is what goes in the line of symmetry. I just put in exactly what b is, not negative b. So this being negative means that this should have been the negative of a negative, which is positive. So actually this should be 2b, this should just be b, this should just be b, and this should just be b. So it doesn't change too much, but it's not going to change this, but it does change this. That part should be negative 2b squared. That's good now. So then I think I'm just gonna combine some like terms. So I'll move the 7 to the left, so we get negative 1, and b squared minus 2b squared is negative b squared. I could multiply by a negative, just basically switch things around. Get b squared is 1, and the b's that do that are plus and minus 1. So for which values of b does this thing have a minimum of 6? Well, these two. If you plug in plus or minus 1, for b here, and you go to like Desmos or something, you'll actually see that this quadratic really has a minimum of 6. There's two different quadratics. Basically, it's like you have like 1 here and like 1 here, but they both have a minimum of 6. That's the idea. So a lot of the most important stuff on this first quiz with quadratics is just knowing what forms to use when you know certain facts. So if you have a quadratic and you know x-intercepts, I want you guys to all think factored form, because factored form is the one that tells you something about the intercepts, right? So I want the actual like quadratic equation that has these two intercepts and has this as a y-intercept, okay? So we know that like for factored form, we have this kind of general equation a, and then like x plus or minus a number, and like x plus or minus some other number. And we know that, if this was like x plus pi, then minus pi is one of the intercepts, right? The x-intercepts. And so we know the x-intercepts are negative 1 and 5. So we know like part of this equation should just be x plus 1 instead of minus 1, and x minus 5 instead of plus 5, right? If you plug in 5, you get 0. If you plug in -1, you get 0. So the only thing we're left to figure out is this number in front here. So we have a y-intercept of 0, 10, which would, that's an x point, and that's a y point on the graph. And so we have sort of 3 unknowns, like x, a, and y, but we can get a because we have another x and y to use here. So I'm basically going to go take these 2 values and just plug them in where they're supposed to go. Y is 10, and then a is what I'm going to solve for. X is 0, and then another x over here is 0. And then this, if I solve it out, I should get what a is. So 10 equals a times 1 times -5. So really just 10 equals -5a. And then again, one of these things that I don't know why that's there. So a is -2. So my final equation would just be y equals -2 times x plus 1 times x minus 5. And you should check it. Go to Desmos, plug this thing in, and you'll see that what we just did is we actually just worked with, the form of a quadratic that we know well, and we were able to figure out the equation just based on 2 intercepts and y, 2 x-intercepts and 1 y-intercept. So I just want to do one more example that's kind of similar to the last one, but a little bit scarier of an answer, and I just kind of want to get you guys used to how these things might not always work out nice. So I want you to find the formula of a quadratic that has this vertex and goes through this point. Okay, so this right here is the big giveaway to me. If it says something about a vertex, you should use vertex form. So, vertex form in general looks like this. And your vertex is just the opposite of this and this number. Not the opposite of this, just the opposite of this one and just this number. So we know the vertex, so we can go and plug things in with that. So we know we have something of the form x plus 1, opposite of -1, and then plus 5. Okay? And then just like before, we know it goes through a point. This is some xy point. And so if we go plug x and y in, we can get the stretch factor in front, all right? So we know y is 41. We know x is -117. So then if we just plug those in, right, we should be able to get a. So if you solve this thing out, if you -5 from 41, you get 36. If you square that thing inside, you get 13,456. And then if you just divide, right, it says a is 36 over 13,456. So then the final answer would just be, that stretch factor in front, and then x plus 1 squared plus 5. And that's it. A big part of quadratics is just knowing how to work with the 3 forms, which is a lot of what we've been talking about in this first part of the unit. So, yeah, it's, if you see some problems like this, and I give you something about a vertex, you should think vertex form. And I give you some other part about the graph, just go plug that in order to fully get the equation. Remember that this is not usually 1 in the world. A lot of times, this stretch factor is something really bizarre, 36 over 13,456. And you should check this one too. Go to Desmos, plug this thing in, and see that it really has that vertex and that it goes through that point.